Okay, this is our last assignment on acids and bases. It's a fairly short assignment, and then at the end is that virtual lab that you're going to do if you said you want to do the virtual lab instead of the actual lab. So off we go. Okay, real quick, let's talk about what acids are. Acids, they have a sour taste. Think of Sour Patch Kids. Their pH values are all less than 7. We'll talk about pH in a minute. Their main species of concentration is the H plus ion in solution or the hydronium ion. They're both the same thing. This reacts with water to give you this, and that's really what's happening. This is the actual species in solution, but we always say it's just the H plus ion. Most, not all, acids start with the letter H in the compound, and I will give you examples of these on the next page. Okay, so here are some examples of acids. So notice that they all start with the letter H in the compound, right? This one has 2. So this is hydrochloric acid, hydrobromic acid, hydrofluoric acid. This is not dihydrosulfuric. This is just sulfuric acid and nitric acid. Acids only occur here when they are dissolved in water, so they have to be in the aqueous form, because HCl by itself, hydrogen chloride, is a gas at room temperature. So when you bubble this gas into water, that's when you get the acid form. Okay, bases on the other hand are called alkaline materials. They are generally bitter tasting. Think of kale, lettuce. Kale is a type of leafy green that's bitter in taste. They have a slippery feel if you put your fingers in them, whereas an acids don't. They have a slippery feel. Soap is a weak base. They end in OH, the hydroxide ion, and their pH is greater than 7. We'll give you some examples of that in a minute. Okay, here are some examples of bases or alkaline materials. Potassium hydroxide, calcium hydroxide, sodium hydroxide, which is a main staple in many manufacturing processes and chemical process, magnesium hydroxide, and here's one, the ammonium hydroxide, right? So you can see these are metals, and here's my ammonium ion. So ammonium hydroxide, that's ammonia that you spray at your house. That is a base. I mean, again, these all have to be aqueous because sodium hydroxide by itself is a solid. It really doesn't become basic until you drop it into water, and then the ions can separate into the sodium ions and the OH ions. Same thing with potassium hydroxide, magnesium hydroxide. Okay, so what's the takeaway from this slide? There's a lot of information going on here. The pH scale is basically the measurement of the concentration of this. The higher concentration of this or this, which is the same thing, this is just dissolved in water, is going to give you a pH value. The lower the number of pH means that there is more of this, and therefore the strength of the acid is increased. Remember, this concentration defines how strong the acid is. Lots of this, strong acid. Not a lot of this, weak acid or even base. Okay, so when we say a strong acid, the pH values would be 0, 1, 2, or 3. It means that we have a lot of the H plus ion and very, very little of the OH ion in solution. Weak acid means that we still have a lot of this, and there is some of this, but not nearly as much as this. Neutral means that we have an equal concentration of this and this, so they balance each other out. A weak base means that we have some of this, but a lot more of this. And then a strong base, or strongly alkaline, means we have a lot of this and very little of this, right? So a lot of this is strong acid, a lot of this is strong base. What does the colors represent, right? The colors represent the color of universal indicator paper, or in other words, pH paper, when you put it into solution. So what you will do is you'll take a strip of this paper called pH paper or universal indicator paper, and you put it into solution, your solution that you're trying to measure the pH, it will change color based on the pH. Depending on what color it changes of one of these is then when you pull it out, then you can determine the pH. So let's say you put the paper in and it comes out orange, then you're going to say, well, the pH is somewhere around 2. Then it comes out medium blue, somewhere around 10. Medium green, somewhere around 7, right? It's not exact, but it gives you the range of where it could be, right? So it's called universal indicator paper, in other words, pH paper. Okay, so let me explain what we're going to be doing in the virtual lab, and then you're going to watch me do the virtual lab, and then I will explain what we're going to be doing after the virtual lab is over with. So what I'm going to be doing is I'm going to be adding red cabbage juice that I've made previously, which is our indicator. An indicator is a very weak base or a very weak acid that will change color when it's in the presence of the other species. In other words, if it's a very weak acid, when it gets to be in a basic solution, it changes color. Now, what's cool about the red cabbage juice is it changes various colors depending on the strength or the weakness of the acid or base that it's in. So that's what's cool about it. It's almost like a universal indicator. In other words, it can indicate over a wide range of pHs. All right. So we're going to watch the lab now, and then we're going to come back and I'm going to tell you what the do after the lab is over.
Okay guys, Dr. Hurley here. We're going to do the lab today. So what we've got is our red cabbage juice, which is our indicator. Indicators are very weak acids or weak base that will change color depending on the situation they're in as far as whether it's basic or acidic. And then we're going to pour it into all these things. So first we've got bleach, lime juice, vinegar, dissolved aspirin, dissolved baking soda, regular tap water from the tap, and ammonia cleaner, right? So we're just going to put a little bit of this in each one. So this just starts out clear, and then we'll put a little bit in, and we'll watch the color. Now you can see the color starting to change a little, and it's starting to go to more of a yellowish. Now we're going to do the same thing with the lime juice. And you can see the lime juice looks totally different, right? Remember it started out purple, now it's more of a burgundy red. What about vinegar? Oh, that looks like it has a similar color. I wonder if there are the similar materials in there. Notice that the bleach one is now more golden orange. What about our friend here, aspirin? Oh, aspirin has more of a purplish thing compared to these other ones. And then we've got some baking soda. Oh, that turned blue. And then tap water. Remember, it starts out purple, so let's see what happens here. Looks like it stays relatively purple, so no color change there. And our last one is ammonia. Ooh, that turned a nice little green color. Huh. Okay, so there you have it. So let's review real quick. Bleach turned a nice golden yellow. Lime juice turned like a nice pinkish red. Vinegar, more of a burgundy purplish red. And we've got aspirin. Baking soda stayed mostly blue. Tap water stayed purplish. And we've got ammonia that is now green. Okay, so what you're going to do is we're going to rank these based on the pH values that you're going to look up on a chart, and you're going to then tell me which one of these is the most acidic and which one is the most basic. So I'm going to let this sit for a few minutes to get the full color. I will take a picture. That's what you're going to reference in your lab, and then you're going to use the worksheet to tell me which one is most acidic, which one is most basic, and then rank them in between. Everybody got that? That's the lab.
Okay, so there you go. You got the lab. So what I'm going to do is in the next slide, I'll show you the picture of all of the ingredients, all of the solutions after they've allowed to sit around for a while. And then I will make a little comment about what the color I see here, so it might come out harder to see on your screen. And then you're going to use the chart that at the end of this particular lab lesson, and you're going to determine what is the pH of that particular material with the cabbage juice in it. Remember, the cabbage juice is going to give you a different color depending on what pH is. And then you're going to rank them from the most acidic solution to the least acidic solution, or the most basic solution. So it's going from most acidic to most basic, all right, based on the colors that you see in the chart. Okay, so in the next slide after this, you're going to see the pictures of all the things that we just did in the lab. I kind of described the colors when we started, right? But you can see here that we have in here, our acidic materials are mostly reddish, pinkish reddish. So it's like a pinkish red, more of a red, purplish red, purple, purplish blue, blue, green, lime greenish, and then kind of yellowish. So it goes, this is the way it goes for the indicator for the cabbage juice, right? Most acidic is on this end, most basic is on this end, weak acidic, weak alkaline, which alkaline and base mean the same thing, and then the neutral pH. So you're going to look at the color, best match it with one of these or one of these down here, and then determine what the pH is. Don't get too caught up with whether it's is it a 7 or is it an 8. If it's closer to 8, just say 8. If it's closer, you think, to 7, just say 7. We're only looking for a relative magnitude compared to the other things, right? So if you're off by 1, it's not a big deal. Right? If you think it's 13 and it's really 14, that's okay. All we're looking for is a ranking system between most acidic to most basic. Okay, so here is a picture of all of this fluids, and I'm just going to quickly go through what I think are the colors to help you out, some of the ones that are a little bit more difficult. So our ammonia would be like a medium green, like a grass cut green. Right? And our baking soda is a blue color. And then you can see here the lime juice. Here's another picture of the lime juice. The bleach is a very pale yellow color. Aspirin would be more of a pinkish reddish color. Vinegar, you can see, looks like a weak cranberry juice, purple. So there's each one of them is in. There should be a picture of each one that you can see here. So let's just make sure we have them all. Ammonia, baking soda, lime juice, bleach. There's a picture of aspirin here. Aspirin's over here. Tap water, vinegar, tap water. So there should be 7 things. 1, 2, 3, 4, 5, 6, 7. And there they all are. So hopefully you can use these colors and what I just said to you to now rank them based on the chart that you saw on the previous page. Remember, this is a medium green, a medium blue or bluish, not purple, bluish, and then a clear, a light yellow. And then if you can see the difference between this red, and this red here. So they're slightly different. So do your best and rank them now based on lowest acidity, most acidic to most basic, using that chart on the previous page.